Welcome to Spelling Bee Ninja, your go-to place for free educational content. If you're passionate about learning and want to deepen your understanding of mathematics, you're in the right spot. Subscribe now to join an amazing community dedicated to exploring fascinating topics and honing skills that truly matter in your academic journey. Today, we're about to dive into the exciting world of exponents, or powers, in mathematics. Let's get started. Did you know that the speed of light, which is approximately 300 million meters per second, can be expressed more simply as 3 times 10 to the power of 8? This is just one of the many ways exponents simplify the representation of numbers. In mathematics, an exponent is a basic concept that acts as a shorthand for repeated multiplication. When you see a number raised to a power, that power tells you how many times to multiply that number by itself. For example, if you have 5 raised to the power of 3, written as 5 cubed, you will multiply 5 by itself 3 times, resulting in 125. Understanding exponents is crucial for tackling many mathematical problems, and they are used in various real-world applications as well. Now, let's break down the parts of an exponent. In an expression like 5 cubed, or 5 to the power of 3, the number 5 is called the base, while the number 3 represents the exponent. Together, they form a power, which is just another way to express multiplication. Next, let's explore what it means to square and cube a number. Squaring a number means that you multiply it by itself once. For instance, 4 squared is 4 multiplied by 4, resulting in 16. Cubing takes it one step further, it means multiplying the number by itself twice. So, 3 cubed equals 3 times 3 times 3, which results in 27. Now, let's dive deeper into the laws of exponents that govern these operations. One important law is how to multiply powers that share the same base. When multiplying powers like 2 to the power of 3 times 2 to the power of 4, you follow the rule of adding the exponents, giving you 2 to the power of 7. Conversely, when you divide powers with the same base, you subtract the exponents. For example, with 3 to the power of 5 divided by 3 squared, you would calculate it as 3 to the power of 3, simplifying it nicely. Another fascinating aspect of exponents is the zero exponent rule. This rule states that any non-zero number raised to the power of 0 equals 1. This might sound surprising at first, but it's a fundamental concept in mathematics. For example, 7 to the power of 0 equals 1. Also, we have negative exponents, which represent reciprocals of the base with a positive exponent. For instance, 2 to the power of negative 3 is equivalent to 1 divided by 2 to the power of 3, which is 1/8. Understanding these various rules enhances your capability to work with exponents in many contexts. The notation itself has a rich history, evolving from ancient times when repeated multiplication was denoted differently. It wasn't until the 17th century that the modern superscript notation we use today was popularized by mathematicians like René Descartes. This transition allowed for a more streamlined approach in calculations and notation. Now imagine how exponents are applied in the real world. They have significant importance in fields like science, engineering, and finance. For instance, scientific notation utilizes exponents to express very large or very small numbers succinctly, such as measuring distances in astronomy, where numbers can become unimaginably large. In finance, understanding compound interest calculations involves exponents as well, allowing you to see how money can grow over time. Population growth, sound intensity, and even computer storage capacity are other areas where you'll encounter exponents regularly. All of these applications show that exponents are not merely abstract symbols in mathematics, they are essential tools for making sense of the world, from the tiniest particles to vast cosmic distances. Look around you, exponents are part of the fabric of many concepts and systems we interact with daily. This whole journey into exponents invites you to think critically and curiously about how mathematical concepts underpin much of the world. To wrap up this lesson, we've unpacked the essential idea of exponents, including their definition and how they serve as a shorthand for repeated multiplication. We identified the base and exponent in expressions and explored the meanings of squaring and cubing numbers. We delved into the laws surrounding the use of exponents, such as how to multiply and divide powers with the same base, the intriguing zero exponent rule, and the explanation of negative exponents. We also touched upon the historical development of exponent notation and discussed the myriad applications of exponents in the real world. Understanding these concepts not only enhances your mathematical skills but also opens up an appreciation for the connections between math and daily life. Thank you for joining us today on this exploration of exponents. We hope you found this lesson both insightful and engaging. If you enjoyed learning with us, don't forget to subscribe for more exciting content that will continue to expand your knowledge and curiosity in mathematics. Until next time, keep practicing, and remember that the journey of learning is always growing. See you soon.